Hello fellow mathematicians, today we're going to be reviewing what we've learnt about fractions. If you look at the learning intentions, it's about understanding how fractions work so we can apply it to equations that involve algebraic fractions. So the same principles apply. So we're going to review how to add and subtract fractions, how to multiply and basically divide because it's nearly the same as multiplying. And then you're going to use what you have remembered, hopefully, or the skills you've acquired to apply it to algebraic fractions, which will be in another video. So the one thing you need to remember is when you add or subtract fractions, you have to have the same denominator. So remember, denominator is the bottom number and the numerator is the top number. And how we do that is we find the lowest common multiple. Now, a lot of teachers I know, you just go, oh, they both go into what's 5 times 9. That works a lot of times, but sometimes when we have things like 9 and 3, the lowest common multiple is 9. So that one we don't have to change. So the 4 on 9, we don't have to change. But I'm getting ahead of myself. Let's have a look at this. 3 on 5, so 3 over 5 minus 2/9. You're probably realizing that in my videos I go through how I think about it. So I look at the 5 and 9, I say to myself, how am I going to get the same denominator? So what's a number that 5 and 9 both go into? Now if I don't know, I'm going to show you the strategy that we use. Right, so what I'm going to do is I'm going to find the multiples of 5, which is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Then I'm going to look at 9, 18, 9 3s are 27, 9 4s 36, 9 5s are 45. Look at that. I now have a number, not that you can see it, that both of them go into. So I need to make the 5ths into 45ths and the 9th into 45ths. So how do I do that? So I need it to be 45 and I need this to be 45. So what I need to do is ask myself, what do I have to multiply 5 by to get 45? That's 9, 9 5s 45. Law of the universe says whatever I do the bottom, I must do the top, because this is really multiplying by 1, so 9 on 9 is the same as 1. 3 times 9 is 27. Okay, for 9, what am I multiplying it by? Is 5. Law of the universe says whatever I do to the bottom, I must do the top, so that's going to be 10. So now I'm going to rewrite my equation so I can, using my equivalent fractions. So 27 on 45 take 10 on 45 equals 27 take 10 is 17, which is a prime number, over 45, so that has to be in its simplest form. So over here, the multiples is a strategy that can help you find what the lowest common multiple would be. If I use that same strategy with 9 and 3, go 3, 6, 9, so 9 times 1 is 9, 3 times 3 is 9, so you'll see that the lowest common multiple equals 9. So this one's already 9, so it's fine. So I only have to change the 3rd to 9ths. What do I have to multiply 3 by to get 9? That would be 3. Law of the universe says whatever you do to the bottom, you must do the top. So it becomes 3 on 9. Rewrite it. 4 on 9 plus 3 on 9 equals 7 on 9. So when you do algebraic fractions, you have to use this same principle or same strategy to find the lowest common multiple. Okay, now onto what's much easier is multiplying fractions. When you multiply fractions, it's just the top line multiplied and then the bottom line multiplied, and then you simplify. So look for the highest common factors and divide. So 3 times 5 is 15, 7 times 18, don't know. So that equals 126. And then if you left that in your calculator, if you put it into your calculator like that, it will simplify it for you. Equals 5 on 42. I personally don't use this method. I use the cancelling out method first, and I will show you. So I ask myself, can I cancel? So I follow my arrows. Can I cancel this way? Is there a number that goes into 3 and 18? There sure is. 3 goes into 3 once, 3 goes into 18 6 times. And then I go, can I cancel out this way? Is there a highest common factor? Is there a common factor between these two? That would be no, especially because they're both prime numbers. Can I cancel this way? No. Can I cancel this way? No. So now I just, 1 times 5 is 5, 7 times 6 is 42. You choose what method works for you. As you can see, I find this much quicker because I don't know my 18 times tables. All right, the beauty of dividing by fractions is that you are basically doing the same function as multiplying. We did do a polypad thing where we explained what dividing by a third looks like. You can play with it if you wish, but we use the strategy of keep the first fraction, change the sign to a multiplication, and then you flip or do the reciprocal of 1 on 3, so the second fraction, so then you can change the function. Alright, what does that look like? So I'm going to keep 7 on 9, so I'm keeping this. I am changing the division to a multiplication, and then I am flipping. So this is change, and this is flip to the reciprocal, which is 3 on 1. Now I'm going to, it's either 21 on 9, or I would, can I cancel that way? Can I cancel that way? Yes, I can. So it becomes 7 on 3. But what we have to do here is simplify this. So highest common factor is 3. So 3 goes into 21 7 times. 3 goes into 9 3 times. So you can see I get the same answer using 2 different methods. We can leave it like that, that's the exact value, but 3 goes into 7 twice, because 2 times 3 is 6 with 1 left over. So that's the answer. So I hope this has helped you remember how we deal with fractions, so we'll be able to use it with our algebraic fractions. So try it yourself. Remember, practice makes progress, and always remember that the best way to learn maths is to do maths. So please have a go.